Good afternoon, students. You know what? You are well known that we are studying the high voltage engineering. So, in the high voltage engineering, breakdown is going to be very important. It may be breakdown in a gases, it may be breakdown in a liquid, and it may be breakdown in a solids. So, up to now, we have seen the two breakdowns. That is the breakdown in gases and breakdown in liquids. Now, at this time, we will see what is the breakdown in the solids. Always remember one thing, that dielectric strength of the solid is always higher than gases and liquids. Gases and liquid solids have a very high dielectric strength. So today we are seeing this breakdown in solids. We know that solid dielectrics of materials are finally used in different electrical circuits for the separation or to insulate one form, one current carrying part from the other one. You are well known with this solid dielectrics. A good dielectric, good solid dielectric should have the property just like low dielectric loss, high mechanical strength, and should be free from gases inclusion and moisture, and be resistant to thermal and chemical deterioration. So these are the good properties of the dielectric solid. These are going to be low dielectric loss, high mechanical strength, free from gases inclusion, free from moisture, and be resistant to thermal and chemical deterioration. Just I have told you that the solid dielectrics have a higher breakdown strength as compared to liquid and gases. So, the study of the breakdown of solid dielectric is very important as compared to the insulation study. One thing always remember, that we are studying the breakdown in gases, we have studied the breakdown in liquids, and now we are studying the breakdown in solids. So one difference between these three is that in the breakdown of the gases, once the dielectric strength of the gases can be lost, it can be regained if the electrical field is removed from that. It means this dielectric strength can be recovered or regained in the case of gases. But in the case of liquid, it is not 100% recovered, but it is partly or partially recovered. But one thing always you remember, that in the case of solid, once the dielectric strength is going to be removed or destroyed, then it is going to permanently destroyed, because it cannot be recovered. It is permanently damaged or permanently removed. So the mechanism of breakdown is complex phenomena in the cases of solid. While we are studying breakdown in gases, breakdown in liquid, but breakdown in solid is going to be studied, is going to be hard to study because of its complexity. Because of its complexity, it is going to be very difficult to study the breakdown in the solids. So when we are going to see the breakdown in the solid, we have to see how many types of the breakdown in solid occurs. Always remember that there are 6 types of the breakdown that are occurring in the case of breakdown in a solid dielectric. First one, intrinsic or ionic breakdown. Second one, intrinsic or ionic breakdown. Second one, electromechanical breakdown. Third one, failure due to treeing and tracking. Fourth one, thermal breakdown. Fifth one, electrochemical breakdown. And sixth one, breakdown due to internal discharge. These are the 6 breakdowns in the solid that is occurring. So we will step by step, we will see what is going to be the intrinsic breakdown. In this case, what happens? So suppose that voltage is applied for a very short duration, just like to 10 raised to the power minus 8 seconds. then at this time the dielectric strength of the solid dielectric increases very rapidly to upper limit called as the intrinsic electric strength. If it is going to be voltage applied for the short duration, just like to 10 to the minus a second, then what happens? The dielectric strength of the solid dielectric increases very rapidly to an upper limit, and that limit is called as intrinsic electric strength. Experimentally, the highest dielectric strength can be obtained only under the best experiment condition when all influences have been isolated. And one thing that should be remembered that this value depends only and only on structure of the material and the chemical. What is the structure? Why we are going to use structure? Because the structure, if there are number of free electrons available in that structure, it means the breakdown state is going to be very less. If there is no free electron, then the dielectric strength of that solid dielectric is very high. And the maximum electric strength recorded is 15 megavolt per centimeter for polyphenol alcohol at a temperature of minus 1960 Celsius. This is going to be the intrinsic breakdown. Now we will come for the second one. That is the intrinsic breakdown depends upon the presence of the free electron. Just I have told you that if number of electrons are 3 or more, dielectric strength is lower. If there is no number of electrons or very less number, then dielectric strength is going to be here in this case. Same thing is given here. Intrinsic breakdown depends upon the presence of the free electrons which are capable of migration through the lattice of the dielectric. When there are free electrons, surely they will move with the migration from where? From cathode to anode. Usually, just I have told you that a small number of conduction electrons are present in solid dielectrics, along with some structural imperfection and small amount of impurities. Some structural imperfection. Why the free electrons are going to be occurring? Along with the structural imperfection. The structure is not perfect, and there is an impurity occurring in that solid dielectric. Then only then small number of electrons are going to be available in the case of solid dielectric. Otherwise, there is no free electrons in the case of dielectrics. These impurity atoms or molecules are both act as a trap for solid conduction electrons up to certain range of electric fields and temperature. When these ranges are exceeded, additional electrons in addition to trapped electrons are released, and these electrons participate in electric conduction process. I have already told you that. Breakdown events, conduction starts. So this is going to be the reason that impurities and the structural imperfection is causing the breakdown in the case of solid dielectric, and this breakdown is nothing but the intrinsic breakdown in the case of solid dielectric. And based on the principle, in the free electron, there are two types of the intrinsic breakdown. First one, electronic breakdown, electronic breakdown, and second one is avalanche or streamer breakdown. What is that? Avalanche or streamer breakdown, and first one is the electronic breakdown. Electronic breakdown, intrinsic breakdown occurs in time of order of 10 to the power minus 8 seconds, and therefore is assumed to be electronics in nature. The initial density of conduction between three electrons is also assumed to be large, and the electron-electron collision occurs. And when to this one electrical field is applied, electrons gain energy from the electric field and cross the energy gap from the valence band to conduction band. Just in the case of breakdown in gases, I have shown you diagram, valence band and conduction band. It means when the conduction valence band is converted into conduction band, surely you can say that breakdown occurs in it may be gases, it may be liquid, or it may be solid. When the valence band is going to be converted into conduction band. When this process is repeated, more and more electrons become available in the conduction band, eventually leading to breakdown. Just I have told that in the conduction band, when the conduction band will occur, when there are there is an avalanche of the electrons. Avalanche equals group, number of electrons. When the avalanche of the electrons are going to be occurring, then only then the breakdown is going to be occurred, and that breakdown is causing in the case of solid dielectric. Second one, that is going to be the avalanche or streamer breakdown. What is that? Avalanche or streamer breakdown. This is similar to breakdown in gases due to cumulative ionization. Just when I have studied the breakdown in the gases, then at this time I would have told you that cumulative ionization. What is this cumulative ionization? It was addition plus 1 to 2, 2 to 3, 3 to 4, 4 to 5. And in this case, conduction electron gets sufficient energy above certain critical electric field and causes liberation of electrons from lattice atom by the collision. At last, what is our problem? What is our fixed point? Our fixed point is that maybe gases breakdown in gases, maybe breakdown in liquid. The process is going to be nothing but the movement of the free electron. When the movement is going to be going on, there is a collision of the electron, and this collision we are studying in the case of gases. Due to this collision, the breakdown occurs, and this is going to be the reason for the avalanche or the streamer breakdown. See here, in this case, under uniform field condition, if the electrodes are embedded in specimen breakdown will occur when an electron avalanche bridges the electrode gap. When we have studied the solid gases, at this time also saying that when the bridges, it means when anode and cathode, when they are bridges by the electron, when the conduction starts, then at this time the breakdown occurs. And in this case, it is called the avalanche or a streamer breakdown if this breakdown occurs in the case of solids. When the energy gained by an electron exceeds the lattice ionization potential, this is the same case we have seen in the case of gases. When the energy gain is double than, or that is more than the ionization potential, then at this time additional electron will be liberated due to collision of first electron. Just when we have studied the breakdown in gases, what we have seen, and especially the breakdown due to collision. This is the same case occurring in the case of solid dielectric, and it is called as nothing but the avalanche or the streaming breakdown. So we will see these two types of the breakdown in the solid up till now. Now remaining 4 types we will see in the next lecture, and that is going to be the total how to happen or what are the different types and what is the difference between these 4-6 types of the breakdown. But we are studying the breakdown in solid. Why it is essential to study different types? Because the reason behind them is very different. The electronic breakdown has a different reason. The avalanche breakdown has a different reason. Intrinsic breakdown has a different reason. So the reasons are behind it. We are studying the different types of the breakdown, and these are going to be the types of the breakdown in the solid dielectric.